आवाज येतो का? हॅलो.
हो, आवाज येत आहे सर.
हा, थँक्यू.
येतोय सर आवाज?
हा. हॅलो. हा, मी डॉक्टर यादव कुमार मावळे, PI कोऑर्डिनेटर, संत गाडगेबाबा अमरावती युनिव्हर्सिटी अमरावती. करता आज या वेबिनार मध्ये आजचे वक्ते विवेक भांगेजी यांचं मी स्वागत करतो. आणि RCI UBA संत गाडगेबाबा अमरावती युनिव्हर्सिटी अमरावती यामध्ये सर्व पार्टिसिपंटचं स्वागत आहे. मी श्री वैभव निचत यांना सूचित करतो की त्यांनी पुढील कार्यक्रमाला सुरुवात करावी, वक्त्यांचा परिचय करावा आणि कार्यक्रमाला सुरुवात करावी.
थँक्यू सर. आजच्या ज्या वेबिनारला लाभलेले जे तज्ञ मार्गदर्शक आहे डॉक्टर विवेक भांगे सर यांचं मी सर्वप्रथम RCI संत गाडगेबाबा अमरावती विद्यापीठाच्या वतीने मनापासून स्वागत करतोय. आणि त्यांचा आज जो वेबिनार आयोजित केलेला आहे तत्पूर्वी मी त्यांचा अल्पसा परिचय करून देतो. सर जे आहे अकॅडमिक क्वालिफिकेशन ME PhD सरांचं आहे केमिकल इंजिनिअरिंग मध्ये. आणि सरांचं एज्युकेशन डिटेल जर आपण पाहिलं तर सर BTech ME आणि PhD सरांचं झालेलं आहे. त्यानंतर सरांचा रिसर्च प्रोफेसर एक्सपिरियन्स जे बघितला तर टीचिंगचा 15 वर्षाचा एक्सपिरियन्स आहे आणि रिसर्चचा 2 वर्षाचा सरांचा एक्सपिरियन्स आहे. आणि सरांनी रिसर्च प्रोजेक्ट असिस्टंट ऍट नॅशनल केमिकल लॅबोरेटरी पुणे सर ऑगस्ट 2006 ते 8 पर्यंत कार्यरत होते. त्यानंतर सर आता असिस्टंट प्रोफेसर प्रियदर्शनी कॉलेज ऑफ इंजिनिअरिंग नागपूर येथे बायोटेक्नॉलॉजी डिपार्टमेंटला कार्यरत आहे 2008 पासून. सरांचे काही पेटंट पण पब्लिश झालेले आहे. त्यानंतर सरांची बुक चॅप्टर 8 पब्लिश झालेले आहे. त्यानंतर पब्लिकेशन मध्ये सर इंटरनॅशनल जनरल 20, त्यानंतर नॅशनल जनरल 2, तर इंटरनॅशनल कॉन्फरन्स मध्ये 10 सरांचे झालेले आहे. त्यानंतर नॅशनल कॉन्फरन्स 15 सरांनी आतापर्यंत झालेले आहे. त्यानंतर सरांचे विविध संस्थेमध्ये मेंबरशिप पण सरांची आहे. मेंबर ऑफ बोर्ड स्टडीज बीटेक बायोटेक्नॉलॉजी RTMNU नागपूर इथे सर मेंबर म्हणून आहे. त्यानंतर लाईफ टाईम मेंबर ऑफ इंडियन सोसायटी फॉर टेक्निकल एज्युकेशन IST इथे पण सर सदस्य म्हणून आहे. त्यानंतर हाँगकाँग केमिकल बायोलॉजिकल इन्व्हायरमेंटल इंजिनिअरिंग सोसायटी इथे पण सर सदस्य म्हणून आहे. त्यानंतर लाईफ टाईम मेंबर ऑफ इंटरनॅशनल सोसायटी ऑफ रिसर्च अँड डेव्हलपमेंट लंडन इथं सरांची मेंबरशिप आहे. त्यानंतर लाईफटाईम मेंबर ऑफ इंटरनॅशनल असोसिएशन ऑफ इंजिनिअरिंग हाँगकाँग इथे सर त्यांची मेंबरशिप आहे. आणि सरांचा जर परिचय करून दिला तर खूप मोठा आहे, पण आपण इथे वेबिनारला सुरुवात करूया. आजचा सरांचा जो टॉपिक आहे वेस्ट टू वेल्थ डिपेंड ऑन हाऊ इट इज द मॅनेज अँड युटिलाइज. ह्या टॉपिकवर सरांना विनंती करतो की त्यांनी आपल्याला पुढील मार्गदर्शन करावं. डॉक्टर विवेक सर.
Hello, can you listen my voice?
Yes sir, येतोय.
Okay, then are you able to see my presentation?
Yes sir.
Yeah.
Yes.
Okay, it is on the whole screen or it's just like in part you can see?
It is, whole screen is visible.
Okay.
You make it
is on the whole screen.
full screen.
Okay,
Yeah,
now
okay.
it is okay.
Full screen, sir. Okay, go ahead.
Okay. So good evening, all the respected professors and dear students. I am very much thankful to Kumbhare sir, Nichas sir, and Yadav Kumar sir that they given me an opportunity to share my research work with you all. So my topic of presentation is waste to wealth, depending on how it is managed and utilized. So first of all, we see the what is mean by waste. So waste is defined as any material.
गडबडमध्ये कसं आहे फायनान्सचा मॅटर आपण गडबडमध्ये करायला पाहिजे.
Hello, sir. Kindly switch off your mic. So, what is mean by waste? Waste is defined as any material resulting from domestic activity or industrial operation for which there is no economic demand and which must be disposed of. So, waste, in another term, we can define waste as any material that is not useful and does not represent any economic value to its owner. So, objective of my presentation is to give you a brief idea how I have converted a waste material into a valuable product. So, different case studies I am going to share with you how I have converted this waste into a value-added product. So, first case study in which I have converted cigarette butts into a adhesive. As everyone knows about the cigarettes and their effects on our body, the pollution caused by the cigarette does not stop in our body.
सर आवाज नहीं येते सर लाऊडली.
Hello.
सर आवाज नाही येत आहे. आवाज मोठ्याने आवाज नाही येत आहे. हॅलो.
Hello. Hello.
सर आवाज नाही येत आहे सर मोठ्याने.
Hello. आता येत आहे?
हो हो हो.
So first case study in which I have converted a waste material into a valuable product is adhesive from cigarette butt. As we know that the cigarettes and their effects on our bodies and as well as the cigarette effects in environment also. After the cigarette is smoked, the use filter is called butt and which is thrown away, which affects the land we live on and the water we drink. The filtering material used is mainly made up of cellulose acetate. Here you can see that every year 6 trillion cigarettes are manufactured globally, which creating 1.2 trillion tons of cigarette butt waste. And it takes 10 to 15 years for complete decomposition of one cigarette butt. So with 5.6 trillion filtered cigarette consumed worldwide in 2002, and it is expected that by 2025, 9 trillion cigarettes will be consumed, then the global environmental burden of cigarette filter is also significant. So it is estimated that 1.69 billion pounds, means here you can see 845,000 tons of butts picked up as a litter worldwide per year. When cigarette waste is thrown out, wind and rain carry it to different places like lakes, rivers, etc. This toxic chemical it contains leach out into aquatic ecosystem and threatening the quality of water and marine life. So aim of my invention is to prepare an adhesive from cigarette butts. So here is the procedure how I converted that cigarette butt into a adhesive. First of all, a cleaning of cigarette butts. Then peel out the cover of butts and grind it into a small fibers. After washing the butts, boil and the fibers so as to remove the traces of nicotine, tar and other harmful chemicals trapped in filter. After cleaning, sun dry the butts and store it in a clean and dry place. Then preparation of solvent mix. In this, animal glue is used in the acetone to enhance the stickiness of the mixture, and that mixture was kept for 20 days. Then extract the solvent using the filter cloth and the solution is used as an adhesive. In third step, cigarette butts are added to the solution which degraded the synthetic polymer cellulose acetate. The slurry form is continuously stirred using a glass rod so as to prevent the lump formation, and after stirring the slurry, it is applied on the different cellulosic material to check its adhesive property. Here you can see how I converted that cigarette butt into an adhesive, which is very helpful in our daily life. Then resultant mix is found to adhere the different materials such as paper, cardboard, wood, metal, marble, acrylic sheet, and has a capacity to substitute the commercial glue. Here I have also compared my product with the commercially available adhesives, and our product is as equal as of quality that is available in commercial market. Recently, I got the patent granted from Indian Patent Office on this my innovative product. Then the second product I have prepared from the waste material is the neem-based bioplastic production from waste banana peels and its sustainable use for green application. As our society is completely dependent on the synthetic polymers, the major product which is of plastic. Plastic consumption is more than that of the world average in developing countries due to their high urbanization and economic development. Over 114 million tons of petroleum-based polymers are generated each year from raw material, crude oil, coal, and natural gas, and applied to plastic with and their derivatives. CO2 and many other toxic compounds are also emitted in the plastic degradation. Plastic is degraded slowly, causing the original product to remain in the landfills for 100 or even thousands of years. Unfavorably, it affects the waterways, lands, and oceans. So here you can see the plastic waste as we see in our daily life. Everywhere plastic material is there. So alternative to this plastic problem is required because it is a global problem. So I have find out one alternative using a bioplastic. What is meant by bioplastic? So bioplastic can be defined as a plastic made from biomass. So bioplastic origin is cellulose, starch, sugars, etc., which are primarily renewable. Starch is a typical source of bioplastic production, and starch-based plastics are served as a promising raw material for manufacturing plastic and safe for environment also. So banana peels are a good point of supply for starch material, and it serves as a large availability, cost efficiency, and environment-friendly properties also. Then reducing the use of non-renewable raw material makes bioplastic from banana peels an effective solution. And after making a bioplastic, I use this bioplastic in a nursery plants. At present, we could see the use of conventional plastic in nursery plants, which raises the serious environmental issues and public irritation because of their non-degradable nature. The potential bioplastic material is alternate over the conventional plastic, and degradation occurs when the soil microbial consortia start consuming these polymers. Eventual release of monomers to environment certainly has a less hazardous effect on the landscape. So in order to create a sustainable environment, the possible disposal of recalcitrant plastic waste in the environment, so the production of bioplastic gain a lot of attention due to their biodegradability. Objective of my work was to produce a bioplastic from banana peels with the addition of neem extract and use that bioplastic as a plant support in nursery for reducing the pollution. And I have also measured the tensile strength biodegradability test of that prepared bioplastic. How I prepared bioplastic from banana peels? I have collected the waste banana samples from the local market. Afterward, banana peel was removed and washed to ensure the proper cleaning. Wash peel was sliced with the scissors in the small pieces. Peels are dipped in 0.2 molar sodium metasulfide solution for 40 minutes. Banana peels are boiled in distilled water for about 30 minutes. Then peels are now left to dry on a filter paper. After drying, a uniform paste is formed. So initially, I have prepared the paste from banana peels. Then neem leaves were collected and washed properly to remove the rust. Then extract is contained in the beaker after crushing the neem leaves and then filter using the filter paper. Purified extract is boiled to increase the concentration. The neem extract is added in 100 gram of banana paste with 0.5 normal SCl and stirred properly. After that, we have added the glycerol as a plasticizer and NaOH for pH maintenance. The mixture was cast into a flat form and dried at a temperature of 60 degrees for 6 hours. Once a bioplastic film was cooled to ambient temperature and stored in a dry condition. After that, tensile strength was measured with the help of universal testing machine of that prepared bioplastic. Then biodegradability test of bioplastic are also conducted. Then microbial testing was done for any bacterial culture or any bacteria or is there to find out on the bioplastic growth of any bacterial culture. Then lastly, we have applied this bioplastic in nursery. The neem-based bioplastic produce has applied in the nursery for plant sample. Plant is being wrapped by the polymeric film such that it has a biodegradable so that it can bury directly into the soil. The growth of plant in the plant support made up of bioplastic with a time interval required for proper growth is also studied. So here you can see the bioplastic sheet which we have prepared from the waste banana peels, which has a natural color as yellowish. And we have also tested the tensile strength, which we found to be 9.13 megapascal. Then in biodegradability test, here you can see the results. Initial bioplastic film we have prepared from banana peels. Then we have buried it in soil for 45 days, and we have watched in between. So after 15 days, here you can see the condition of that bioplastic film after 30 days and completely degraded after 45 days. These are the different stages showing the biodegradation of bioplastic film. Then microbial testing. In microbial testing shows that there is not much growth of fungus in the petri plates containing the bioplastic. Since the neem-based bioplastic has a pesticidal properties, as we already used a neem extract in bioplastic, so microbial contamination is not there. So we have used that neem-based bioplastic in nursery. Here you can see the bioplastic we have used for plant support in nursery. As we know that currently we are using the plastic polythene bag for plantlet support, but we have replaced that plastic bag with the help of bioplastic we have prepared. So here we can directly put this plantlet support into the soil and it will automatically degrade after 45 days. And as neem extract is used, so it will act as a pesticide. So figure shows that the plant growth in a plant support made from the bioplastic with the time interval required for proper development. The neem-based bioplastic film produce has a pesticide properties. Plantlet support is completed by letting the plant be wrapped with bioplastic and buried directly into the soil. The neem also has a pesticidal property, therefore plant gets the fertilizer directly and bioplastic is used to prevent environmental pollution and it is easily biodegradable and can be transformed into simpler molecules. Bioplastic does not get accumulated in nature. That is the property of bioplastic. Where the conventional plastics are a petroleum-based plastic and required high amount of energy for production. So neem-based bioplastic is the bioplastic which is partially restrict and attack the small pest. The neem has a natural pesticidal features which prevent the bioplastic from the pests and which damage the integrity of bioplastic, thus results in a weak heat of bioplastic. So neem work as a pesticidal effect here. The prevent the damage pesticide property of neem is helpful. They can be made in various colors and have aesthetic look for the consumers to buy. And they certainly would not cause any pollution as their composition is entirely from the biomasses and does not contain any toxin. Then on this work that I have prepared bioplastic from banana peels, I have present this in international conference at Kyrgyzstan near to Russia, and I got the best paper award for this work. Then the third case study, as conversion of a waste material into a product, is characterization of grey water in an Indian household and designing of on-site grey water treatment system. So 700 liter of grey water generated per household per day in India. And India has a total 249.5 million households, which does not include hotels, hostels, institutions, and other commercial setups. Around 200 billion liters of grey water is generated in India every day. 200 billion liters of grey water is generated. Okay. So what is grey water? Grey water is the wastewater produced as a result of our household activities like bathing, from kitchen sink, wash basin, laundry, and is classified as a grey water. Here you can see the grey water sources. So what is the need of the treatment for grey water? As India being a highly populated, tropical and drought-induced country and has a need of for the development of grey water reuse system, as the grey water consists of suspended solids, high pH, high turbidity, bacterial contaminants. These can direct or indirect harm to the both animals and the plants, and they can be a cause the various diseases. Publicly, the grey water is not accepted. So here we can see the contribution of various sources of grey water. We have done one small survey from where we get the grey water in a single household. The average values we put here that from laundry there is 21%, wash basin 9%, kitchen sink 32%, and bathing 38%. The characteristics of grey water vary depending on the number of family members, their age, and usage. The grey water generated from bathroom consists of high amount of shampoos. Laundry grey water consists of high amount of detergent. Sink grey water contributes to soap, toothpaste. The grey water generated from kitchen sinks have a high amount of food residues, oil, etc. So treatment studies, in that case, we have prepared, design a filter system for reuse of grey water and different layers of material we have used in that filter. For example, sand, gravel, fly ash, banana peels, wood chips, coconut husk, etc. The filter unit was composed of height 100 centimeter and width 30 centimeter. Then characterization of filter layers. So first filter layer we have used is a sand filter layer. Sand taken comprising a mixture of gravel and a small pebbles. Various components were separated using sieves of different sizes. Fine sand was obtained by separating using a 1 mm of pore size. Sand filter help to reduce COD, BOD, TSS levels of wastewater as they have irregular geometric shapes. Another layer is use of fly ash tree clumps, which has the ability to reduce the surfactant, oil, and grease present in the water. The surface roughness facilitates the absorption of oil and on grease particles on the surface of clumps, and this we have used of size 1 to 2 centimeter. Then third one is the coconut husk. The coconut husk was first washed with the tap water and then sun drying. This acts a good adsorbent, removes dye components. Then another filter we have used is the wood chips. The bark of neem tree for scrap and wood chips of minimum width of 1 centimeter was prepared. These chips were then we have sun dried it. Then neem wood chips are seen to impart antimicrobial property, reduces the odor of the water. Then the last layer we have used, which is of from banana peels. Banana peels were cut into small pieces of 2 centimeter and they were sun dried. And these facilitate the removal of metal ions and organic compounds. So the prepared filter, here you can see the schematic representation of the filter So, in making the filter, we have used all the waste material for designing the filter for grey water treatment. So here, the removal capacity of filter, you can see the table signifies the removal efficiency of the filter layer we have used. That is the BOD percentage removed, COD percentage, turbidity, total suspended solid, and chlorine. That the results we have got here mentioned. The filter worked efficiently for a duration of 80 days. After that, pores started blocking in the sand filter and efficiency was reduced. Then application and reuse. So here we have convert grey water into a usable form, but we cannot directly use for in our daily purpose. But there are some applications of that grey water. Here we have suggested a system for reuse of that grey water. Here you can see the in tank number 1 is a fresh water tank where the supply for all our household. Then tank 2 is the grey water collection tank. Here we have collected one in one tank the grey water from one house. Then after passing through this filter, which is 0.3, then collected the grey water in tank number 4. And this grey water we can use for toilet flushing, our garden purpose, watering garden purpose, then washing of the washing car. As well, we have also did one small experiment in which fenugreek seeds were planted in the pot with 2 kg oil capacity. 1 minute. मॅडम राहू द्या, माझं लेक्चर आहे, नंतर तुम्ही लॉक राहू द्याल. हा तू राहू, नंतर मी लॉक लावून देईन. So here fenugreek seeds were planted in a pot with of 2 kg soil capacity, where 2 plants were evaluated. In one plant we have used normal water and another we have used grey water. Same growth was observed in both the plants and with the same leaf color and the same lifespan. Here you can see the growth by fresh water and growth by grey water. So this work, conversion of grey water into a usable water, is recently published in Science Direct. You can refer in Water Energy Nexus journal. Then another case study of waste material to value-added product is utilization of orange peels for mosquito repellent and solid biomass fuel pellet. India is one of the largest orange producer country, and around 40 to 60% of oranges used in juice production, out of which 50 to 60% comes out as a waste. In India, tons of citrus peel waste are produced every year in food processing industry, which can be used to produce some useful materials. This food industry based waste product gets dumped in a dumping yard every year. It is found that this peel waste can be used to produce significant value added product instead of dumping. Mosquitoes are vectors of variety of pathogens or major disease which cause health problem and turn into one of the important issue in India. We are also facing a mosquito problem in our daily life. So in this context, people are working on different techniques to resolve the issue. Nowadays, commercial mosquito coils and chemicals based repellent are used in home, but smoke affects the respiratory system of human beings. Therefore, we have developed repellent from a natural source as an alternative for synthetic chemicals, which makes the area unpleasant to mosquitoes to prevent human from mosquito bites. In Nagpur region, large amount of oranges is produced, as we know that, per year, in which is used in the orange industry. So we have collected the orange peel waste from industry to extract orange oil, which is mainly limonene and pectin. And limonene is well known for its antimicrobial property. The purpose of the present study is to utilize this peel waste into useful product, that is mosquito repellent. So here you can see we have converted this waste banana orange, banana waste orange peels into a mosquito repellent. And after conversion of orange peels, into a mosquito repellent, that orange peels are which are remains after extraction of limonene, we have converted into a pellets, which has a good calorific value, and we can use it as a heating purpose. The use of natural ingredient ensures no irritation on the applied skin and no side effects. The mosquito repellent we have prepared, we have tested it. There's the use of natural ingredients. We have used orange peel, which is natural. So no irritation on the applied skin and no side effect. Such formulations result into reducing the toxic effect of synthetic mosquito repellent on human body. This indicates that orange peel extract could be used for control of vector-borne diseases. It provides long-time protection against mosquito, safety, environment sustainability, no side effect and irritation to the skin. We also produce fuel pellet from the residue of orange peels. This fuel pellet exhibit a good calorific value, which made this product promising in the field of heat application. So, this conversion of orange peel into mosquito repellent, the paper is also available on a Scopus Index Journal, Research Journal of Chemistry and Environment. The same work I have published in that journal. Then last case study, in which another product I have prepared is an iron corrosion remover from Bottle Goure. The present invention relates to the corrosion of metals, especially the iron, which is inevitable within the industry and housing. Corrosion occurs due to the oxidation and reduction reaction between material and its environment. The deterioration of metals in an environment of application is inevitable. Metal corrosion has drained the world economy and has caused a loss of valuable property. In numerous industrial applications, including metal building, manufacturing, and transportation, iron is one of the most significant and often utilized metals due to its accessibility and affordable price. However, iron structure is extremely sensitive to the corrosion under numerous circumstances, including moisture, corrosive agent, and polluted atmosphere. So metal corrosion has drained the world economy and has caused a loss of valuable properties. The present invention relates to the corrosion of metals, especially iron, which is invisible within industry and household. So here you can see some pictures of corrosion in which we fight or found in our daily life. So how I solve this problem? Using a natural source. It has been reported that a lack of corrosion prevention led to increased cost for issues such as repair, maintenance, rehabilitation, as well as the replacement of damaged installation. The kinds of literature and available techniques suggest that still there is no method to control corrosion, stop it completely. You can use any paint or whatever, but we cannot stop completely corrosion. So corrosion cost worldwide increased to USD, that is US dollar 2.5 trillion in 2013, accounting for 3.5% of global GDP. Here you can see the global GDP in which 3.4% we have to spent on corrosion. So here you can see the severity of corrosion problem. With this regard, it is necessary to develop an environmentally safe corrosion remover for iron. So how I prepared a corrosion remover? So I have prepared corrosion remover using bottle guard. In Marathi, we call it as a lauki. So first, I have collected the bottle guard from the local market, and then cutting the bottle guard into small pieces, and we extract the juice from that bottle guard. Then we have added some aluminum powder, cassava starch, lemon juice, and alum powder in that mixture, and the prepared solution was agitated for 10 minutes on the magnetic stirrer. Now the product is ready for use, which removes the corrosion instantly. Here you can see the result for corrosion remover, which we have prepared in our lab from bottle guard. This figure shows the whole corrosion layer or rust we have removed from that iron rod, and this one is unreacted, and this product is so instantly removes the corrosion. There are another few examples here before and after using the corrosion remover. Then advantages of our product. So our product is suitable for handling, transport, preservation, and usage. A composition is provided for use in cleaning the surface of iron metal. SCL or H2SO4 is used in commercially available corrosion remover. You can see the corrosion remover, it is available in the market, but mainly hydrochloric acid or H2SO4 used in that corrosion remover spray. The acid they are using cause rapid corrosion in case of iron. If we clear the corrosion, it again get corroded because the acid is used there. So our proposed invented product is a cost effective and no chemical base instantly remove corrosion, which is our novelty. And this corrosion spray we can prepare in rupees 70 of 1 liter, whereas the market remover spray is 400 to 500 for 400. So we know the applications of corrosion remover in our daily life: automotive maintenance, metal fabrication, marine industry, household items, industrial machinery, then infrastructure maintenance, aerospace industry, historical artifacts restoration, some projects, electronic industry. Everywhere we can use the corrosion spray. So recently we have put this our research work under patent. So that is under process. So in all the case studies, I have converted a waste material or organic material into a value added product to reduce the pollution, or my aim is to generating a wealth, to generate the wealth from the waste material. As my mainly focus area is environment. Here a 2-minute small video. Are you able to see this video?
Yes, sir. Yes, sir.
Okay. So my message is clear. Don't make pollution. Before making pollution, think again. Within this 1-minute video, you can take some lesson. So in conclusion, it is our duty to building a future in which people live in a harmony with nature and never underestimate the dangers in which the environment can cause. We fail in our responsibility, and remember one thing, it begins with you and me. So the message I want to convey you all, that be the part of solution, not a part of pollution. Thank you.
Thank you very much, sir.
Thank you, sir. Dr. M. Kumbar, coordinator. Hello.
Continue, sir.
Hello.
Any questions?
Your voice breaking, sir. Kumbare, sir.
Hello, am I audible, sir?
Yeah.
Okay, sir. Yes, thank you. Myself, Dr. M.B. Kumbhare, coordinator of RCA, Sant of Amravati University. So, sir, first of all, I welcome. I appreciate Vivek Bhangre sir for accepting our invitation and give a guidance on the waste to wealth topic. So, thank you very much, sir. Sorry, I'm just late ho gaya, so that's why Maure sir, I'm very thankful, Maure sir, for starting this session. So thank you very much, Maure sir, also. Any from participant side, any questions regarding on this topic, so you can ask.
First of all, I'm very much thankful to Dr. Vivek Bhangre sir, because really this webinar is really worthful, because today's topic is waste from waste or wealth from waste. So, and related to pollution and environment. So really all the case studies are really good, and he has got the patent also, but the presentation is very nice and very useful, because whatever he presented here, all the things around us, and which is the waste material. But Dr. Bhangre sir converted this waste material into useful and useful daily life material, and which is really well created. So thank you very much for this good information, and I hope the participants from this UBA platform, they will learn and try to make some other products also from this guidance. So now over to Kumbare sir. If anybody want to ask the questions to Dr. Vivek Bhangre sir, you are most welcome.
Sir, 1 minute. Rahul Goure sir want to ask one question. I just going to unmute, sir. Rahul Goure sir, please unmute your mic. Rahul Goure sir. Sir, please unmute your mic. Rahul Goure sir. Okay, sir. I have one question.
Sure.
Hello,
Yeah.
Bhangre sir.
Yes.
Bhangre sir.
Yeah, sure.
Okay. Sir, my question is that you are preparing the mosquito repellent from the orange peel.
Right.
So what technique you are using, sir, here to just simple steam distillation or any
Yeah,
different,
simple
different technique you are using?
No, simple steam distillation. I have extracted the limonene and different three basic studies I have performed, and then we have tested. I will show you the paper, sir. Directly you can refer this. So detailed idea you will come to know.
Okay.
The
So
detailed
if
procedure
you are
is
using
there.
only simple distillation.
Yeah,
for this.
simple distillation.
It's
Nothing
very
else.
easy to just make that mosquito
Yeah,
repellent in the
is
villages
very,
also.
yeah, it is very easy. But
Villages people can prepare that and they can sell it
yes.
as a product.
Yeah, and the material which is left after preparation, we can use that material for our we can use in the replacement of coal because it has a good calorific value.
Okay. Thank you, sir. Any
1
question
minute
from participant
to-
side? Rahul Gavai, sir. Please
Sir, this
unmute
is
your
the
mic.
paper which is available on Research Journal of Chemistry and Environment. You can refer.
Okay.
I have published this in 2019, which is a Scopus Index journal. So you can take the screenshot and total process it is written and how we have tested the mosquito repellent is also.
राहुल गवई सर, आप सुन रहे हैं क्या? राहुल गवई सर, आप अनम्यूट कर लिए अगर आपको कुछ पूछना है तो आप अनम्यूट कीजिए. हेलो.
Okay.
Conclude, sir.
Okay. So thank you, sir. Thank you very much for accepting our invitation and giving a guidance on this topic best to well. Really, this sir has explained very well regarding the bioplastic from the banana peels and the neem-based bioplastic also. Sir has also explained related to the Greywater treatment. So that is also a very wonderful technique we can implement in the villages also. Then sir has also explained related to utilization of the orange peel for making a mosquito repellent and solid biomass fuel repellent. Sir has also explained related to the corrosion prevention also. So these techniques or that methods, that's very, very wonderful, and that all we can try to implement in the villages, and at least we can provide the knowledge regarding this these topics or these projects. So that should be what exactly beneficial for our villagers, and they can prepare their product. They can prepare that product and make they sell there, and they can earn some money from this. So really, this topics is what it's very, very wonderful, sir. So I thank you once again, Dr. Vivek Bhangre sir, for accepting our invitation and guiding us in this occasion or in this on the topic best to wealth. Thank you very much, sir. Thank you very much. And I also thankful for the. I'm so thankful to the participant who are actively participant in this webinar. Thank you all the participants. I also thankful our PI Dr. Maure sir for taking the initiative and starting this webinar in absence of me. So thank you, Maure sir. Thank you very much. And yes, I with this regard, I just want to stop here. So thank you all. Thank you very much.
Thank you, sir, for giving me this opportunity. Special thanks to Kumbare sir.
Yes,
Nicholas sir.
sir, in future आप यहाँ पे इस तरह से इस टॉपिक कुछ नए टॉपिक्स पे आप हमारा गाइडेंस करेंगे, इसलिए
Sure,
हम
sure, sir. I am
आशा करते
working
हैं.
on another different 3 or 4 topics, which is patentable topics, and I always work on waste to wealth. So I try to make some good product from the waste material.
If
And,
any PI want to some hands-on training regarding this topics or regarding this project, so they also can just organize one what exactly the training on their villages also, so that it is very beneficial. तो मुझे लगता है कि आपने इस प्रोजेक्ट पे हैंड्स ऑन ट्रेनिंग अगर किसी को चाहिए होगा तो सर सर उसके ऊपर गाइडेंस करेंगे मेरे ख्याल से. So thank you sir, thank you very much. तर मग इथेच आपण थांबूया असं मला वाटतंय. मावळे सर. इसको स्टॉप कर.